Thanks very much for having me. It's really nice to be invited by Professor Kopstein and Professor Wong to send in that dancer to start off the lecture. That guy's going to be a hit at weddings for about the next 4 years. After that, it's just going to be irritating. Okay, so what I want to talk to you about today is something which we normally associate with science, which is the use of experimental methods to learn something about the world. Okay, what I want to do by the end of the class is give you a sense of how political scientists use experiments and use experiments that have the same logic as experiments in the hard and proper sciences to learn about the political world. The reason why Professor Kopstein asked me to do it was because I'm a political scientist, but I'm an experimentalist. And about 90% of the work I do outside of my teaching is involved in using experiments to answer questions about democracy. So I use experiments to answer questions like, why do some people vote and other people not vote? I've used experiments to understand why some people in African villages cooperate with other people and others don't, and how this matters for the creation of wealth and the benefit of their societies. I've got a big experiment running in Mongolia right now, which tells us about the relationship between having property and how much you're willing to cooperate with people and how much what your political preferences are. So experiments in political science really cover a really wide swath of questions. So what I want to do today is I want to give you a sense of what we mean when we're talking about experiments, what an experiment is, and what an experiment is good for. And then I want to give you a sense of the types of questions we can answer using experiments that maybe we couldn't answer using the other methods of political science. So just before I start, all the way at the back, you can hear me fine? That's the case? Great. Okay. I want to start with a story, which I think is a very nice story, which illustrates some of the principles of experiments, and it's just sort of a nice story to begin with. It's a story about one guy named Ronald Fisher and one woman named Muriel Bristol. Muriel Bristol. Okay? Now, how many people here are tea drinkers as it happens? Okay. That's a lot of people. And how many people here put their milk in first before the tea? How many put the tea in before the milk? How many people think they could tell whether someone had put the milk in before the tea or the tea before the milk if they were handed? You think you can know? Okay. So some of you are like Muriel Bristol then. Okay? So this story begins with Sir Ronald Fisher, who's really the father of modern statistics. Okay? He was a scientist at Cambridge University at the Rothschild Experimental Institute in Britain in the first part of the 20th century. He had some pretty unsavory views of humanity and politics as it happened, but that aside, he made some really great contributions to statistics. He was, as it happened, a pretty good Englishman, so that meant that he was a tea drinker. Okay? But he was also a person who attended a lot of parties around Cambridge, England. And one day he was at a party, and he met Muriel Bristol, who I couldn't find a picture of, so I've got this. And even if that was her picture, you wouldn't remember her face, right? So Muriel Bristol is another scientist and a colleague of Ronald Fisher's. You can imagine that a woman who was working as a scientist at that level at that time would have to be very smart to overcome all the gender discrimination that was there. So she was quite a smart lady. And Fisher served her tea one day. Excuse me. And she insisted that Fisher had put the milk in the wrong order and that she could tell. And Fisher thought, this is absurd. There's no way you can tell in what order the milk has gone into the tea. But Muriel Bristol was convinced that she could. So, you know, academics like to sort of debate and answer and quibble over really kind of silly things. So what they decided they would do is they would run an experiment to see whether Muriel Bristol could actually tell whether milk went into the cup first or whether tea went into the cup first. Okay? Parenthetically, does anybody here know why in British society high-class people would put the tea in first and working-class people would put the milk in first into their tea? Because when you were poor and you had cheap china, putting hot water or hot tea into your china cup could break it. So you put the milk in first to cool it down, and then you put in the tea. And people with good china could do the opposite. Muriel Bristol, I think, liked to have her milk in first for whatever reason. Fisher was convinced she couldn't tell. So what they did is they said, we'll do the following, okay? Fisher will make 8 cups of tea. In half of them, he'll put the milk in first. In the other half, he'll put the tea in first. Okay? Then he'll randomize the order of the cups of tea. He'll give each of them in succession to Dr. Kristol. She'll try the tea, and if she can guess the order, or she can guess which ones had the milk in first, which ones had the tea in first, then she'll have proven to Fisher that she could do this. Okay, that she knew in what order things had gone in. So the first thing was, Fisher made all these cups of tea. The second thing he did is, he randomized the order of the tea. Okay? Why would he randomize the order of the tea? He actually used a series of coin flips, I think, to decide in what order the 8 cups of tea would be put out. But what's the purpose of randomizing the order? Well, one of the reasons is because he wants to make it really difficult for Dr. Kristol to understand or guess what order the teacups are in, right? So he just does it randomly. But the reason why he used a coin to decide, rather than just mixing it up himself, is because humans are actually really bad at writing out a random sequence of numbers, right? Or doing things in a random order. So if I ask you to write 30 digits, okay, from 0 to 10 in some random order, okay, and I compare that to an actual random order of numbers, more often than not, a little bit of math, you can figure out which one was your order and which one was the random one. Humans are bad at doing things randomly, or trying to do things randomly. So, Kristol is giving these 8 teacups in a random order. Fisher doesn't know the order of the cups, and Kristol doesn't know the order of the cups. She drinks all 8. I've already spoiled it for you. She identifies them correctly. Okay? She knows all 8 in a row. So 2 questions come out of that. One was she just lucky? Could she just have randomly guessed the order of those cups of tea? And the second is, how could we know that she was that she did it by luck rather than by skill? Now, if she guessed 5 of 8, we'd be less certain that she knew the order, right? But we might think that she had a pretty good idea. If she guessed 3 of 8, we'd probably say, well, she probably doesn't know the order, right? If she guessed 0 of 8, we'd be almost positive. But how do we quantify it? Well, you don't have to memorize this, and I ask that you don't. But Fisher developed a statistical test to figure this out, okay? It's called the exact test, and now we call it the Fisher exact test. And this is why we know about this case today, okay? But using this formula, Fisher, the statistician, is able to calculate that the odds that Muriel Kristol could have got 8 cups of tea in a row correct, just by chance, were 1 in 70. Okay? So this, you're going to see, is a very good example of an experiment, and a good one, because there's some question we want to answer, which is, can you know the order in which milk's been put in a teacup? Okay? There's a method for figuring it out, so they go half and half with milk first or tea first, and they randomly order them. And then there's measurements afterwards. And the measurement gives you some idea of how sure you are of something. Okay? These are all the components of an experiment. We'll talk about them in detail in a few moments. But this is how we can know this. Now, it turns out that this is, I think, a pretty trivial question, right? Whether milk goes in tea first, or tea goes in the cup first. Okay? But what I want to show you is, I want to show you all the other sorts of things. There's some other things which we can learn from experiments. So I can maybe convince you that even if you're a social scientist, learning about experiments, thinking experimentally, is well worth your time. So, here's what we're going to do today, okay? I'm going to tell you what's important about experiments, okay? The first thing I'm going to do is I'm going to tell you that we can learn from experiments. I'm going to tell you why we can learn from them. And I'm going to tell you that they're important because they allow us to test people's claims, to sort of use some rigor to see whether what people say about the world is true. Okay? A lot of political science is people asserting that something is true, that democracy is good for economic growth, that democracy is good for women's rights, that war is never a solution to a problem. Okay? We make all sorts of claims in political science. We make claims about what the just life is. Okay? Some of these claims can't be tested, but other ones can. Okay? So what I want to do over the course of the lecture is show you what's important about experiments and why they're useful for questions of political science, not only for trivial questions of the ordering of milk and tea. Okay? And then what we're going to do is show you what the components or the actual parts of experiments, and what you need to have a definitional experiment. And they are treatment and control, randomization, and measurement. And I'll tell you more about each of those as time goes on. So here's the game plan. I'm going to give you an idea of some important questions that I think experimentation can answer. I'm going to give you a really precise idea of what I mean when I say an experiment. I'm going to give you an idea of why we do them. Okay? When you see what an experiment is, the logic of it, the reason for it, will become clear. The logic's built in. So once you know what an experiment does, then you know why you would want to use an experiment. Okay, so when I'm giving you the definition of an experiment, ask yourself what's useful about each of these parts, okay? And it'll reveal to you why an experiment's useful. I'm going to tell you about types of experiments, so like the classification. And then I'm going to tell you about 3 experiments that I think are pretty cool, but there's dozens, okay? One is an experiment on federalism and representation that I've conducted. One's an experiment on what's called clientelism and voting in Benin in West Africa, conducted by a very smart guy named Leonard Wanchicon. The third one, and this is the one that's going to be most relevant for tomorrow because of the American election, is an experiment on something called facial confidence in voting. It's one of the cooler experiments I know about. Okay? And then I'm going to tell you about, in a self-serving way, I'm going to tell you about a chance for you to complete some experiments for extra marks. Okay? So you got to stick to the end for that one. Okay. So here are some of the kinds of questions we can answer with experiments, and that I'm going to give you some answers for today from real experiments. One is, does federalism lead to better representation? In Canada, we live in a federal country where we have a federal or a national government in Ottawa, and we have a government in Ontario, just over the road at Queen's Park. If you live in Saskatchewan, you have a government which represents you in Regina, and you have the government in Ottawa which represents you. Okay? If you live in Alberta, it's Edmonton and it's Ottawa. Right? We have 2 levels of government, official levels of government. In other countries like France, there's just one official level of government, which has a seat in Paris. And the question is, are we better represented, are we better off if we live in federal countries or if we live in unitary states? These are really important questions, right? Because countries today that are emerging as democracies, Afghanistan, Iraq, even places that are sort of worse off in the world, are asking themselves, should we set ourselves up as a federal country, or should we set ourselves up as a unitary country? As a country with 2 levels of government, or as a country with 1? And it turns out there's a bit of experimental evidence on which one is better. Another question, this may seem rhetorical to you, but are voters superficial? Do voters really care about the policy of candidates? Do they care about what candidates have to say, what they believe about the world? Or do voters just care about how a candidate looks? Okay, I'm going to show you results from an experiment that are really surprising, even shocking, about how much a candidate's appearance matters. Okay? Even in just a very, very quick glance. And then I'm going to tell you about an experiment which answers this question. How do we stop patronage and instead get public goods? Especially in countries that are poorer than our own and that are developing, there's a real conflict for politicians. And politicians are often faced with a choice. Do they give money to people in their ethnic group and to smaller groups of people or to their friends? Or do they create goods that are for the benefit of everyone? And they have strong incentives in both ways. I'm going to tell you about an experiment that allows us to see what happens when politicians try to give up public goods rather than patronage. And then we can answer questions of these. I do lots of experiments with this question as to whether contact from a political campaign actually matters in an election. I won't show you an experiment about that, but that's really a question we can answer. Okay, so let's start by defining experiments. I've talked a lot about what I mean by experiments and what they can do and why they're important so far, but now I just want to give you some definitions about what I really mean by experiments. And you'll see that the 3 experiments we'll talk about have these conditions, and the experiment we just talked about with Drs. Fisher and Kristol, in fact, have had these characteristics as well. So these are the 3 sort of definitions of experiments or characteristics, and then we're going to use an example from your class to see how we can answer a question experimentally. Okay? So the first thing that an experiment has to have is it has to have what we call treatment, or it has to have conditions. Okay? It has to have some stimuli or something, okay, that some people are exposed to at some point in time and are not exposed to at another point in time. Or it has to have something which some people are exposed to and other people aren't exposed to. Okay? So in a medical experiment on painkillers, the treatment would be taking an aspirin, taking ibuprofen. Okay? In an experiment on whether winter tires make a car safer than all seasons, the treatment would be putting winter tires on a car or putting all-season tires on a car. Okay? So there has to be some stimuli you're administering and measuring. Okay? In the case of Fisher and Bristol, it was, did the milk go in first or did the tea go in first? Those were the 2 treatments or the 2 conditions. And then what we call assignment to treatment, okay? Or, well, let's say assignment to treatment for comparison groups has to be random. The process of the randomization has to be known, okay? The administration of the treatment has to be random, it has to be known. Well, this is might be a bit of a confusing thing. We'll talk about it in a second in the context of this question regarding Professor Kopstein and his ties. And then there has to be an ex post measurement of the results. So an experiment's a process. You have to have some treatments and some conditions. You have to randomly assign them to your subjects. And then you have to measure the results. And absent any of those things, there's not an experiment. So let's use this example. So you've only been in the class for a couple of months, but apparently Professor Kopstein's famous for wearing flashy ties, okay? And I was going to wear a tie today, but I became a professor, so I wouldn't have to wear ties ever. It's the best job in the world. But okay, so let's ask this question. Does Professor Kopstein teach better when he wears a tie? I mean, this is probably one of the most burning empirical questions out there. Okay? Everybody wants to know. Okay. So let's talk about what we mean more by treatments, and then we'll use this example of Professor Kopstein to illustrate this. Okay? So a treatment is a stimulus, okay, or a series of stimuli. It's anything that's thought to have an effect on some outcome. Okay? So a treatment is something that you think changes the behavior of people or actors in the world, and it changes people when they're exposed to it. Okay? In the context of an experiment, a treatment is something which is applied to some people, but not to others. Okay? It can't be that everybody gets a treatment. Okay? Or it's applied at some times and not others. Okay? So if we want to use the example of trying to understand whether Professor Kopstein teaches better when he wears a tie, then the treatment would be he could wear a tie for every second lecture, for example. Okay? So if you came to the first lecture of the month, there would be no tie. If you came to the second lecture of the month, there would be a tie. Okay? The treatment would be your exposure to his tie, his magical tie. Okay? So it's that simple. So as I said, in the case of a medical experiment, the treatment would be the drug. So some people get a placebo or a sugar pill, and some people get the real drug. Okay? If I wanted to understand how sending you a letter encouraging you to vote had an effect on your voter turnout, the treatment would be getting that letter. Some people would get the letter, some people wouldn't get the letter. Right? Some people might get 10 letters, some people might get 5. Okay? But the treatment is any stimulus. And some people have to get the treatment and some people can't, or they have to get it at different times. And then there has to be random assignment. Okay? And the idea here is we have to put some subjects or some people in our study, okay, into treatment, and some have to be put into control. And we have to do it randomly. Okay? What do you think it means to say that we do this randomly? It doesn't mean that we do it haphazardly, right? So in sort of colloquial English, or idiomatic English, we'll say, oh, I just got a totally random question for someone, right? Which means that I got a question out of nowhere, right? Or that guy's totally random. He's strange or something, I guess. But what we mean in this case, okay, is that whether you get the drug in the headache study, for example, or whether you get the sugar pill, is random, which means it's entirely independent and unrelated to anything about you. Okay, it's independent of the conditions, or of your own conditions. So what we would do if we were doing, for example, this experiment with Professor Kopstein, is we could flip a coin before every class to see whether he wears a tie. Okay, we would just take a quarter, we'd flip it up, and we'd say, if it's heads, you wear a tie, if it's tails, you don't. Now why would we do that? Why would we use that random method? Because we wouldn't want Professor Kopstein choosing to wear a tie in a class when he thought he was going to teach well. Right? Because imagine that he puts on a tie when he's teaching material he really likes, he doesn't wear a tie when he's teaching material he doesn't like. Okay? Well then, the tie's not doing anything, it's just that he likes some classes more than others and he teaches some better than others. Right? So you have to make it random. It has to be independent of every other thing. Okay? So experiments have treatment and control, and that treatment and control is administered randomly. This is why, if you know anything about medical trials or experiments generally, you will hear people refer to RCTs, or randomly controlled trials. Okay? Randomly controlled trials. And then finally, there has to be some measurement of the results. Okay, so for an experiment to be complete, we need to know what the effects are. And what we want to measure are causal effects. And the way we can do this is we can measure exam performance at the end of the year. Right? So we can say, okay, there were 16 weeks, and in 8 of those weeks, Professor Kopstein wore a tie and 80 didn't. And let's look at each section on the exam and ask, did people do better on the topics in which Professor Kopstein wore a tie, randomly assigned, or did they do better in topics in which he didn't wear a tie, or is there no statistical difference? And that's how we would figure out if there's any relationship between his wearing a tie and your performance in class. So, I've told you we sort of have to have all 3 of these parts, and indeed it's true that we do. Okay, we can't have an experiment absent having all 3 of these components. So, to summarize our example, what we have is that we have the question, is Kopstein better when he wears a tie? The treatment is wearing a tie or not. The random assignment is flipping a coin before class, and the measurement is exam results. And what I'm going to show you is, if we knock out one of these conditions, one at a time, we don't have an experiment, right? So, imagine this. Imagine Kopstein always wore a tie, okay? The treatment was he always wore a tie, and we flipped a coin before class to decide whether he was going to wear a tie or going to wear a tie. We looked at the exam results. We could never know what the effect of his wearing a tie is because we wouldn't have observed how he taught when he didn't wear a tie, right? So the treatment has to have some variation. You have to have his wearing a tie and his not wearing a tie. Or imagine that we had the treatment wearing a tie, okay? And some days he wore one and some days he didn't, but he decided on his own when to wear the tie. This just simply wouldn't work, right? Because we wouldn't know if differences on exam results were a function of his wearing a tie or whatever caused him to choose to wear the tie that day, right? Maybe he wears a tie when he's feeling very smart and he teaches better, or vice versa. And then finally, we could have him wearing a tie as a treatment. We could use a coin flip to decide when he wears the tie. So we know the first 2 components. But if we didn't measure the exam, okay, we wouldn't have an experiment because we wouldn't know the results of it. So what this tells you then is that to have an experiment, we have to have all 3 of these parts. In the logic of necessary and sufficient conditions, if you notice, all of these things are necessary conditions for an experiment. And I'm going to go a step further here. I'm going to tell you that to make a causal inference, we have to have all 3 parts. Okay? I want to say that as you go farther in academia and in your school careers, if you haven't heard this phrase before, causal inference, it's a phrase you're going to hear more and more and more, because it's sort of an advanced concept. But more than that, it's one that's growing in the social sciences increasingly. Okay? So every year, more and more social scientists become concerned with making causal inferences. One of the reasons why I do experiments is because it helps us make a causal inference. Okay? And you're going to see that it's more and more important to understand how to make these. By causal inference, I mean I mean a statement where I would say, if there's X, then Y. That's a causal statement, a causal inference. Okay? If you exercise more regularly, you will be healthier. Is a causal inference. Now, it turns out that making causal inferences, making causal effects, is pretty tough. Okay? You're going to see why in a second. So, a causal effect, okay, is the difference in outcomes between 2 states of the world, one treated and one untreated. Okay? In the context of Professor Kopstein, there's just a very little bit of notation here. Okay? We would say that a causal effect is the effect of some outcome, Y, let's say it's the exam, okay? When you're treated minus when you're untreated. So the causal effect of Professor Kopstein wearing a tie is exam scores for topics where he wore a tie minus exam scores for topics where he didn't wear a tie. Okay? That's how we make the causal inference. We look at performance in one state of the world, less performance in another state of the world, and if there's a difference between those 2, then we know there's a causal effect. Okay? This could be any number of questions. And economists, for example, use this to answer all sorts of important questions. So they'll ask questions like this. What is the effect of going to university on your income? Okay? What is the effect of going to university on your lifetime income? And an economist may say, what would be the effect of you going to university less you're not going to university? What would your income be if you went to university, minus what would your income be if you didn't go to university? The difference is the causal effect. Why is that problematic? Why is that very difficult to do? Think about one more example. What's the effect of my having a headache, okay, if I take an aspirin? And what's the effect of my having a headache if I don't take the aspirin? In both cases on Saturday morning. So I wake up on Saturday morning and I say, I want to figure out the causal effect of this aspirin. I'm going to take an aspirin, observe how much of a headache I have, then I'm going to not take an aspirin and observe how much of a headache I have. The problem is, I can't be in both of those places at once. I can't be in both of those states of the world at once, right? I can't know what my income would be if I had not become a professor because I became one, right? So the fundamental, what we call the fundamental problem of causal inference. The fundamental problem of causal inference is that you can never observe a subject in both their treated and their untreated state. Okay? You can never observe this person having gone to university and having not gone to university, because they can only be in one state. This is one of the fundamental problems of causal inference. So think about this in a social science standpoint. Someone says, what would have happened to the country of Iraq had the government of the United States and its allies not invaded Iraq in 2003 or 2004? What would have happened? Well, we can speculate, right? But we can't know for certain because we haven't seen Iraq having not been invaded during that period of time. We don't know. Okay? This is the fundamental problem of causal inference. The reason why experiments help us overcome this is because they use random assignment to put people into conditions. So, one way we can do this experiment might be a terribly cruel way, and I wouldn't be able to get it through ethics. But the way we would do it is, we would just have everyone in the class line up, and we'd flip a coin, and we'd say, okay, if it comes up heads, you have to leave university today. If it comes up tails, you get to stay. A year from now, we'll look at the average income of everyone who left the class and everyone who stayed in, and we'll see what the effect is on your income. That, of course, is a total hypothetical experiment. It's not going to happen. But it's a way in which we can understand whether going to university for a year improves your income or decreases it. Okay? And we would only know that because we randomly put some people in one group, and we randomly put people in another group. Okay? And on average, and here's perhaps the most important point, on average, those two groups are the same. Okay? The level of intelligence in those two groups divided by one group is the same. The level of initiative, the level of prior education, the type of upbringing, it's all the same on average. So looking at the outcomes between those two groups and comparing them, we can understand what a causal effect is. Now I want to say something that if you believe this, okay, then it really changes the way you see the world, right? Because you start to wonder how much we can know about anything unless we can be sure that everything is the same between two cases, except for some small change, okay? When we look at two countries and we say, what's the effect of one country having a federal system, the other country having a unitary system on their wealth, for example? Unless we can hold everything else constant, we have a hard time knowing what the effect of being in the federal state is. Okay, so in the context of our experiment, the causal effect is going to be exam results with the tie minus exam results without the tie. Okay? As long as these experiments are done properly, we can know the effects. I will tell you, I still haven't convinced Kristol to do this experiment, but next year I'm very hopeful. Okay. So, now, what I want to ask is, why do we do an experiment? Okay? So why do it? Well, the first one is because we want to make causal inferences. We want to know something about the world, and we want to know whether our x's in the world actually cause our y's. Okay? We want to know why, for example, how a